Right now, the government office that watches the entire country for violent weather has written a sentence it almost never writes about New England. Strong tornadoes are possible this afternoon over the woods of Maine. Not Oklahoma, not the open plains. Maine. And here is the part that should stop you cold. The very same weather system putting rotating storms over the northern forests is, at this exact moment, drowning the Texas hill country 1,000 miles away, dropping 8 to 10 inches of rain on ground that cannot drink it. One pattern. Two disasters. Pointed in opposite directions on the same afternoon. That is what forecasters rarely ever see, and millions of people are sitting on its edges tonight without even knowing it. If you want to understand how a single dome of air can throw tornadoes at Maine, and a flood at Texas at once, and where it goes next, tap that like button and subscribe to the Sky Lab, because this pattern is not finished yet. And drop a comment telling me where you're watching from, and whether the skies look strange where you are today. Now, let's get into it. Part 1. The words, forecasters, rarely right. There is a sentence sitting inside today's official forecast that almost never gets written about this part of the country. The Storm Prediction Center, the government office in Norman, Oklahoma that watches the whole nation for severe weather, has told the public that strong tornadoes are possible this afternoon and evening across western and central Maine. Read that again slowly. Not the Great Plains, not Oklahoma or Kansas, or the flat open country where these words belong. Maine, the northern edge of New England, up where the maps turn to forest and lake, and the towns get small and far apart. That is where the government is saying the sky could do something today that it has almost no history of doing. To understand why that single line matters so much, you have to understand what the people who write these forecasts are actually trained to hold back. Forecasters are conservative by nature. Their entire profession is built on not crying wolf, on choosing the calmer word when two words are available, because a warning that fires too often is a warning people learn to ignore. So when a forecaster in the middle of July looks at the data coming out of the computer models over northern New England and chooses to write the phrase strong tornadoes, that is not hype. That is a professional who has looked at the numbers and decided the calmer word would be a lie. And that is the first thing you need to sit with today, because the entire story we are about to walk through hangs on it. The official label for the threat is an enhanced risk. On the Storm Prediction Center's 5-level scale, that is a 3 out of 5. Level 1 is marginal, the kind of thing you barely notice. Level 2 is slight. Level 3, enhanced, is the level at which forecasters expect numerous severe storms, some of them intense, capable of doing real and widespread damage. For the Great Plains in spring, a level 3 is a normal Tuesday. For northern New York and northern New England in the middle of July, it is the kind of thing that makes meteorologists lean toward their screens and start double-checking their own eyes. The risk area today reaches across the top of New York State and stretches deep into the northern woods of Maine, and inside that zone the official hazard list reads like something copied out of a plains forecast and pasted into the wrong region. Multiple tornadoes are possible. Some of them could be strong. Damaging straight-line winds are on the table, isolated gusts over 75 miles an hour, which is hurricane force. Hail is expected, large to very large isolated stones over 2 inches across, which is bigger than a golf ball and closing in on the size of a baseball. Any one of those threats on its own would be a notable day for northern New England. Today all of them are stacked into the same afternoon, in the same place, driven by the same overhead pattern. That is the anomaly at the centre of this video, and every piece of what follows connects back to it. Now, I want to be honest with you about where this stands, because honesty is the whole point of this channel. As of the time this forecast data was pulled, in the early afternoon, there had not yet been a single confirmed tornado, a single damaging wind report, or a single hail report anywhere in the country today. 0. The threat is a forecast, not a finished event. The ingredients are loaded into the atmosphere, the setup is on the board, but the storms have not yet done what the forecast says they can do. There is even a wrinkle in the data where the automated product that lists active tornado watches was running on an old timestamp from the day before, which means we cannot fully trust it to tell us what is or is not in effect at this exact moment. So this is not a story about devastation that has already happened. This is a story about a loaded setup and the millions of people sitting underneath it while the clock runs. And that is a more unsettling place to stand in a way. When a disaster is over, you at least know its shape. You know how big it was and where it hit and who it spared. Standing here in the hours before, all we have are the ingredients and the pattern and the professional judgment of the people whose job is to see it coming. They are telling us the northern woods of Maine could see a strong tornado today. The reasonable response is not panic, and it is not dismissal. It is attention. Here is the part that turns a regional severe weather forecast into something bigger. This threat over Maine is not a local accident. It is not a random storm that popped up over the wrong state. It is one edge of a single, enormous atmospheric pattern that is anchored over the middle of the country right now, and that same pattern, at this same moment, is doing something violently different 1,000 miles to the south. While Maine braces for rotating storms and hurricane-force gusts, the Texas Hill Country is drowning. One system, two disasters, pointed in opposite directions at opposite ends of the country on the very same day. That is what forecasters rarely ever see, and that is why millions of people are in the way. Let me put a frame around just how unusual the Maine piece is, because the numbers only mean something once you know what normal looks like. Tornadoes are not unheard of in New England. The region averages a handful most years, and they do occasionally turn deadly. But the tornadoes that reach the far northern interior, up near the Canadian border where the elevation rises and the air is usually cooler, are rare, and the strong ones, the ones rated significant on the damage scale, are rarer still. The atmosphere up there usually lacks one ingredient or another. Either there is instability but no wind shear to organize it, or there is shear but the air is too stable to build tall storms. It is unusual for all the pieces to arrive at once in the right amounts over that specific ground. Today they have. The reason they have arrived is the same reason Texas is flooding, and the same reason the plains are baking under record heat, and I am going to show you exactly how one overhead feature ties all three together as we go. But it starts here, with a sentence a careful forecaster chose to write about a place that almost never earns it. Strong tornadoes are possible over Maine this afternoon. Everything else follows from why that sentence exists at all. It is worth understanding just how much weight that little scale carries, because it is the language forecasters use to speak to the whole country at once. The Storm Prediction Center issues its outlook categories every single day, for the entire United States, and on the overwhelming majority of days the vast bulk of the country sits at nothing at all, or at most a marginal or slight risk. An enhanced risk is genuinely uncommon anywhere, and the office does not hand them out casually. When you see one drawn over a region, it means the forecasters expect not just a stray strong storm but numerous severe storms, several of which could be intense. Now take that already uncommon designation and place it where it almost never goes, over the top of New York State and into the Maine woods in July, and you begin to see why this particular outlook made meteorologists across the Northeast sit up. It is the meteorological equivalent of a hurricane warning being posted for a mountain town. The category itself is not exotic, its location is, and there is a specific piece of language inside these outlooks that matters even more than the category, which is the wording about tornado strength. Forecasters distinguish carefully between the possibility of a brief weak tornado and the possibility of a strong long-track one, because the two are worlds apart in the damage they do. Weak tornadoes are far more common everywhere, including the occasional one in New England. The phrase strong tornado is reserved for setups where the atmosphere genuinely supports violent, well-organized rotation reaching the ground. That the office used that stronger phrase for Maine is the single most telling detail in the entire forecast, and it is the thread we're going to follow all the way through. So the question that pulls us into the rest of this is deceptively simple. How does a summer sky over the northern forests of New England, a place built for canoe trips and cool evenings, suddenly load itself with the same raw materials that fuel the violent storms of Tornado Alley? What are the actual ingredients, and what makes their arrival here, now, so strange that the professionals whose whole job is caution decided the honest word was the alarming one? To answer that, we have to open the atmosphere up and look at the two numbers doing the heavy lifting. Part 2. Why 2,000 joules over Maine is the anomaly. Every severe thunderstorm on Earth is a machine that runs on two things. It needs fuel, and it needs a way to organize itself. Take away either one, and the machine either never starts or falls apart before it can do damage. Today, over the northern edge of New England, both are present in amounts you would expect to see in Oklahoma in May, not Maine in July. So let me hand you the two numbers that forecasters are staring at, and then let me translate them into something you can actually feel. The first number is the fuel, and meteorologists measure it with a mouthful of a term called convective available potential energy. Everyone just calls it CAPE. Think of CAPE as the amount of stored energy in the atmosphere waiting to be released the instant a bubble of warm air starts rising. When the sun heats the ground and the air near the surface gets hot and humid, that warm air wants to rise, the way a hot air balloon rises. If the air above it is cooler, the warm bubble keeps accelerating upward, faster and faster, and all that upward motion is the engine of a thunderstorm. CAPE is measured in joules per kilogram, and today the atmosphere over northern New York and northern New England is forecast to hold somewhere between 2,000 and 3,000 joules per kilogram. To give you a sense of scale, a few hundred joules per kilogram is enough for ordinary summer thunderstorms. 1,000 is a healthy, severe setup. 2,000 to 3,000 is the kind of raw fuel that builds towering, violent supercells. And over Maine, in July, that is genuinely strange. This is not a region that usually stores that much energy in its summer air. The second number is the organizer, and it is called wind shear. Shear is the change in wind speed and direction as you climb up through the atmosphere. Picture the wind near the ground blowing gently one way, and then, a few miles up, the wind screaming much faster from a different direction. That difference, that twisting change with height, is shear. And shear is what separates a garden-variety thunderstorm from a rotating monster. Without shear, a storm's updraft and its rain-cooled downdraft end up on top of each other, and the storm chokes on its own cold air and dies. With strong shear, the updraft and the downdraft get tilted apart, so the storm can sustain itself for hours, and crucially, that twisting wind can start the whole updraft rotating. A rotating updraft is called a supercell, and supercells are the storms that produce the strongest tornadoes and the largest hail. Today, the effective shear over the threat zone is forecast at 50 to 60 knots. In plain terms, that is a very strong, very well-organized wind profile. It is more than enough to spin storms. So here is the anomaly, stated as plainly as I can. You have plains-level fuel, 2,000 to 3,000 joules per kilogram, sitting directly underneath plains-level organization, 50 to 60 knots of shear, and it is all parked over the northern forests of New England in the middle of July. That combination is the meteorological equivalent of finding the ingredients for a desert flash flood in the middle of a rainforest. Each piece can show up on its own. It is the two of them arriving together in these amounts over this ground that almost never happens, and when it does, the result is exactly what the forecast warns about: rotating supercells, large hail, and the possibility of a strong tornado, all in a place that has very little practice dealing with any of it. I want you to hold on to why this is happening, because it is the spine of everything in this video. The fuel and the shear did not wander up to Maine by accident. They were delivered there by the same overhead pattern that is right now drowning Texas. That is not a metaphor, and it is not a coincidence. It is one physical system with a north edge and a south edge, and northern New England happens to be sitting on the sharp, dangerous north edge. Keep that image in your head as the numbers pile up. Now, numbers like CAPE and shear can feel abstract, so let me ground them in what they actually build. When you have this much instability and this much shear, the atmosphere does not make one gentle storm. It makes discrete cells, meaning individual, separated storms that each get their own supply of unstable air, rather than one big smeared-out line where the storms compete for fuel. Discrete cells are the dangerous kind, because each one can pull in the full environment around it and organize into a rotating supercell. In a high-shear, high-fuel environment, a discrete supercell is the setup most capable of producing a strong tornado. That is precisely the concern for this afternoon, especially in the early phase before the storms crowd together into a line. There is one more ingredient that deserves a mention, because it is quietly making everything worse today, and that is the heat at the surface. Before these storms fire, the region is baking. Temperatures in parts of the threat zone are pushing into the upper 90-degree range, exceptional for northern New England, and that heat is not just uncomfortable, it is storm fuel. The hotter and more humid the air near the ground, the more violently it wants to rise once something lifts it, and the more CAPE the atmosphere stores. So the same heat that has people cranking their air conditioners today is physically loading the gun. The record-challenging warmth and the tornado threat are not two separate stories. The heat is one of the reasons the storms can get so strong, and that points at something I need you to really absorb before we go further. Today is not a day with three unrelated weather problems that happen to land on the same date. The heat feeds the storms. The storms ride the same steering flow that is pulling floodwater into Texas. Every hazard we discuss traces back to one anchored feature in the upper atmosphere. Pull that one feature out of the sky, and all of it collapses at once. That is why the honest way to tell this story is not as a list of separate warnings, but as a single pattern showing you every violent thing it is capable of, all in one afternoon. There is a subtler ingredient hiding inside that sheer number, and it is the one most directly tied to tornadoes specifically, rather than just to strong storms in general. It is the turning of the wind with height near the ground, what meteorologists call low-level directional shear, and the spin it creates is measured as helicity. Picture the wind at the surface coming from one direction, and just a few thousand feet up, coming from a noticeably different direction. That change does not just speed the storm along, it imparts a horizontal corkscrew-like spin to the lowest layer of the atmosphere. When a storm's updraft tilts that horizontal spin into the vertical and stretches it, you get the rotating column that can become a tornado. In a northwest flow setup like today's, with strong winds aloft and a favourable turning near the surface, that low-level spin can be present, and it is one more reason the forecast holds the tornado threat open, rather than calling for straight-line wind alone. There is also a gatekeeper in all of this, and it explains why the worst of a day like today so often waits until the afternoon and evening. Frequently there is a warm, stable layer a mile or two up called a cap or a lid that temporarily holds the rising air down, like a pot lid keeping water from boiling over. The cap lets the fuel build all day without being released, storing more and more energy underneath it. Then, when a triggering mechanism finally punches through, all that stored energy is released at once, and the storms that break the cap tend to be the most explosive, precisely because they have been holding back a full day's worth of accumulated fuel. That delayed, all-at-once release is part of why the dangerous window today is expected in the late afternoon and evening rather than the morning. So we have the fuel, and we have the organizer. We have plains-grade ingredients sitting over New England. But ingredients alone do not explain the geometry of today, the strange fact that these storms are going to come at New England from the wrong direction entirely, sliding down from Canada instead of sweeping up from the southwest the way severe weather almost always does here. That backward geometry is the fingerprint of the exact pattern, responsible for the whole day, and once you see it, you cannot unsee it. Let me show you the shape of the thing that is doing all of this. Part 3. The pattern tilted 90 degrees. Severe weather in the eastern United States almost always arrives from the same direction. Storms ride up from the southwest toward the northeast, following the warm air ahead of a cold front, marching along a line you could draw with a ruler. People in New England, without ever thinking about it, have learned that rhythm in their bones. The sky darkens in the southwest, the wind picks up, and the storm rolls through from that corner of the horizon. It is so consistent that it has shaped how the entire region reads the weather, and today, that rhythm has been thrown out entirely, because the pattern overhead has been rotated almost 90 degrees from what it should be. To see why, you have to picture the feature at the centre of this whole story. Anchored over the middle of the country right now is an enormous dome of high pressure in the upper atmosphere, a ridge, a mountain of warm air that bulges upward and forces everything to flow around it. This is the same heat dome responsible for the record-challenging temperatures across the plains, and I'm going to keep coming back to it because it is the single object tying this entire day together. For now, just hold the image of a giant stationary dome parked over the centre of the map. The jet stream, the fast river of wind that steers weather systems, cannot go through that dome. It has to go around it, and it goes around the top. So on the northern edge of the ridge, the flow is not coming from the southwest at all. It is screaming in from the northwest, sweeping down out of Canada and across southern Quebec toward New England. Meteorologists call this a northwest flow regime, and it is the fingerprint of exactly this kind of blocking pattern. Instead of storms climbing up from the southwest, today's storms are going to form up over southern Quebec and slide down the top of the dome toward the southeast, crossing the Canadian border and spilling into New England from above. It is, as one way of describing it goes, like a slide pointed straight at the northern states, with storms sledding down it. That backward geometry is not a curiosity. It is the reason the threat lands where it does, on ground that rarely sees it. The storms are being manufactured over Quebec, in that pocket of exceptional instability we talked about, and then the northwest flow is carrying them down into northern New York, northern Vermont, New Hampshire, and Maine. The very direction of the flow is what aims the danger at the far northern interior instead of the usual southern New England corridor. And because the flow comes from the northwest out of Canada, it is also dragging cooler air aloft over that hot, humid surface, which steepens the temperature difference between the ground and the heights, which, as we covered, is exactly what pumps up the storm fuel. Every piece of this reinforces every other piece. That is what a well-organized severe setup looks like. Now hold this pattern next to what it is doing on its other side, because this is the heart of the whole video. The same dome that is sending storms sledding down its northern edge into Maine is, on its southern and western edge, spinning its flow the opposite way and pulling deep tropical moisture up out of the Gulf of Mexico and jamming it into Texas. One dome. On the north side, a fast, dry northwest wind that builds rotating storms. On the south side, a slow wet flow that dumps floodwater over the same ground for days. The clockwise circulation around a high-pressure system does both of those things at once, automatically just from its shape. This is not two weather systems that happen to be active on the same day. It is one system showing you both of its faces. I keep emphasizing this because it is genuinely the thing that makes today rare, and it is the thing ordinary weather coverage misses. If you watch the news tonight, you will very likely see a Maine tornado segment and a Texas flood segment treated as two separate stories with two separate reporters. The atmosphere does not see them that way. To the atmosphere, they are the same pattern. The tornado risk and the flood are physically joined at the ridge, the way two ends of a seesaw are joined at the pivot. Push one edge down and the other edge goes up. That is why the honest headline is not tornadoes in Maine or floods in Texas. It is one dome, two disasters, and millions of people living on its edges. There is a reason forecasters find northwest flow events particularly tricky, and it is worth knowing because it feeds directly into the uncertainty we have to be honest about. In a normal southwest flow setup, the storms in the front are relatively predictable in their track. In a northwest flow regime, the storms often develop as fast-moving complexes that can either stay as discrete, rotating supercells, or quickly congeal into a bowing line of wind. Which one happens matters enormously. Discrete supercells are the tornado threat. A bowing line is more of a widespread damaging wind threat. Today's forecast holds open both possibilities, which is part of why the hazard list is so long. Early in the event, if cells can stay separated over and just north of the border, the tornado risk is real. Later, as they merge and race southeast into New England, the threat is expected to shift more toward a wall of damaging wind. The same storms, evolving through two different kinds of danger as the evening goes on. So the shape of the day is set by the shape of the dome. A ridge parked over the centre of the country, a northwest flow raking its top, storms built over Quebec and aimed down at the northern forests, and a mirror image wet flow feeding a catastrophe in Texas off its other flank. Once you can see that single object in the sky, the whole day stops looking like a coincidence and starts looking like exactly what it is, which is one pattern operating at full power. It is worth naming the family this pattern belongs to, because it has a formal identity in meteorology. When the jet stream develops these big stationary bulges and dips instead of flowing smoothly from west to east, forecasters call it a blocking pattern, and it comes in a few recognizable shapes. One is called an omega block, because the flow traces out the shape of the Greek letter omega, a big ridge in the middle with a trough of low pressure carved out on either side. These blocks earn their name from what they do, which is block. They stall. The normal eastward progression of weather grinds to a halt, and whatever is happening underneath any part of the pattern keeps happening, in the same place, for days. That stalling is the reason today's Texas rain is a multi-day event and not a passing afternoon storm, and it is the reason the heat under the ridge can build to record levels. A block is a pattern that refuses to move on, and that refusal is where a lot of its danger comes from. There is one more physical detail on the north edge that sharpens today's threat, and it is the temperature of the air high above the surface. Because the flow up there is coming down out of Canada, it is dragging cooler air aloft over the hot, humid surface air of the region. That widens the temperature contrast between the ground and the heights, and meteorologists call the rate at which temperature drops with altitude the lapse rate. Steep lapse rates, cold aloft over warm below, make the atmosphere more unstable because a rising bubble of warm surface air stays warmer than its surroundings for longer and keeps accelerating upward. So the northwest flow is not just steering the storms, it is actively steepening the environment they form in, feeding the instability, making the updrafts more violent. Everything about the geometry conspires in the same direction, towards stronger storms over ground that rarely gets them. But a pattern on a map is still an abstraction until it becomes a clock. The real question for anyone living underneath this today is not the shape of the ridge. It is the timing. When do the first storms fire over Quebec? When do they reach the border? And when does the danger arrive over the towns of northern Maine and New Hampshire after dark? Because the hour these storms cross into New England turns out to be one of the most dangerous details of the entire setup, and it is where we go next. Part 4. The timeline, from Quebec to the border to the dark. A severe weather threat is really a story about time. The same storm that is a curiosity at 2 in the afternoon can be a life-threatening emergency at 10 at night, and the difference is not the storm. It is where you are in the day when it reaches you. So let me walk you through the expected clock of this event, and pay close attention to the last chapter of it, because the hour these storms are forecast to arrive over New England is one of the most dangerous parts of the whole setup. It begins to the north in southern Quebec. Through the afternoon, as the sun does its work on that hot, humid, unstable air, the first storms are expected to fire over the Canadian side of the border. This is the birthplace of the threat, the pocket where the instability is most extreme and where the earliest supercells are most likely to spin up while they still have open, unobstructed air around them. If you are anywhere in southern Quebec through the afternoon, that is the leading edge of the danger, the first place the sky turns serious. From there, the northwest flow takes over as the conveyor. Remember the geometry, the storms sledding down the top of the dome toward the southeast. Through the late afternoon and into the evening, those storms are forecast to track down toward the international border and then across it, into northern New York, northern Vermont, New Hampshire, and Maine. This is the window when the threat transfers from Canada to the United States, and it is also, unfortunately, the window when the storms may be at their most organized, still holding together as discrete rotating cells before they begin to merge. The communities across the far north of these states sit directly in that path. Burlington and Plattsburgh on the New York and Vermont side, up through the small towns of northern New Hampshire like Berlin, and across the great northern stretch of Maine toward places like Jackman and Bangor. These are the names inside the risk zone tonight, and here is the detail I need you to really register, because it is the one that quietly raises the stakes on everything. This threat is expected to run into the evening and potentially well after dark. Nighttime tornadoes are a different and deadlier animal than daytime ones, and the reason is painfully simple. You cannot see them. During the day, a person can look to the southwest, see the wall of a storm, see the lowering of a funnel and make a decision. At night, all of that visual warning vanishes. The storm is a sound and a pressure change, and, if you are lucky, an alert on your phone. Study after study has found that tornadoes that strike at night are far more likely to kill than tornadoes of the same strength that strike during the day, precisely because people are asleep, unwarned, and unable to see what is coming. A region that already has almost no practice with tornadoes is now looking at the possibility of one arriving in the dark. That combination, inexperience and darkness, is exactly the combination that turns a survivable storm into a tragedy. This is where I want to connect the timing back to the pattern, because the darkness is not bad luck. It is a consequence of the geometry we already walked through. The storms are born over Quebec in the afternoon, and have to travel south into New England, and that travel time is what pushes their arrival over the border communities into the evening and overnight hours. The same northwest flow that makes this setup so rare for the region is also what schedules its most dangerous phase for after sunset. The shape of the dome does not just decide where the danger goes, it decides when, and the when is working against the people in its path. As the evening wears on, the expected evolution shifts. Early on, the concern is discrete supercells and the tornado threat that comes with them. Later, as the individual storms race southeast and start to collide and merge, forecasters expect the threat to broaden into damaging straight-line winds, a long push of hurricane-force gusts capable of snapping trees and knocking out power across a wide area. So a family in northern Maine could face two different faces of the same system in one night. First, the sharp, localized, rotating threat of a possible tornado, and then, behind it, the broad hammer of a wind event moving through the dark. By the overnight hours, the whole complex is expected to weaken and push off to the south and east, and the threat winds down. But the hours between arrival and exhaustion are the ones that matter, and they land at the worst possible time of day. I have to keep pairing this northern timeline with what is happening at the other end of the pattern, because they are running on the same clock, driven by the same dome. While New England moves through its dangerous evening, Texas is not waiting for a single afternoon of storms to pass. Its disaster is measured in days, not hours, a slow catastrophe of rising water that does not care whether the sun is up. The north edge of the dome delivers a violent few hours. The south edge delivers a relentless few days. Same system, two completely different shapes of danger, unfolding simultaneously. Let me put a real number on why the after-dark timing is so serious, because it is not just intuition, it is documented in the research. Studies of decades of United States tornadoes have found that tornadoes striking at night are roughly twice as likely to be deadly as ones striking during the day, even when the tornadoes themselves are of equal strength. Twice as likely, and the reasons are exactly what you would expect. People are asleep and do not receive warnings. People cannot see the storm approaching, and so do not believe the threat until it is on top of them. People in vulnerable housing have no time to relocate to somewhere safer. The tornado is no stronger at night. It is the human circumstances that change, and they change entirely for the worse. Today's forecast places the most dangerous window squarely in that after-dark period for much of northern New England, which means the same storm that might have been survivable at 3 in the afternoon becomes considerably more dangerous at 11 at night. The evolution of the storms through the evening also matters for who is at risk and when. In the earliest phase, over and just north of the border, the storms are most likely to be discrete and rotating, which is the phase that carries the highest tornado potential. As they push south and east into New England and begin to interact and merge, the classic expectation is that they organize into one or more bowing lines, and the dominant threat transitions from tornadoes to a broad swath of damaging straight-line wind. This means a single community could experience the threat change character over the course of an hour or two, from the sharp, localized danger of possible rotation to the wide, sweeping danger of a wind event tearing through in the dark. Understanding that progression is part of understanding what to watch for as the night unfolds. None of this timing is guaranteed, and I want to keep saying that, because a forecast timeline is a best estimate, not a promise. The models disagree on the details. Some runs are faster, some slower, some keep the storms discrete longer, some line them out sooner. As of the data behind this forecast, not a single severe storm had yet been reported anywhere in the country today, which means everything I have just described is still a projection waiting to be tested against reality. The value of walking through it is not to frighten anyone. It is so that if you live under this tonight, you know the shape of the evening ahead, you know that the dangerous window is after dark, and you know to have a way to be warned while you sleep. So we know what the ingredients are, we know the shape of the pattern, and we know the clock. What we have not yet done is look at what these storms can actually do when they reach the ground, the specific violence the forecast is warning about, from stones of ice falling out of the sky to winds strong enough to level a tree line. That is what turns numbers on a map into a real threat to real homes, and it is where we turn next. Part 5. Ice, the size of baseballs, and wind that snaps a tree line. Let me make the threat physical, because so far we have been talking in the language of forecasts, and forecasts can feel weightless until you translate them into the objects and forces they actually describe. The official hazard list for today has 3 headline items beyond the tornado itself, and each one deserves a moment, because each one is capable of injuring people and destroying property entirely on its own. Start with the hail. The forecast calls for large to very large hail, with isolated stones over 2 inches across. 2 inches does not sound like much until you picture it. A 2-inch hailstone is bigger than a golf ball and pushing toward the size of a baseball. Now consider how it arrives. Hail forms high in a storm's updraft, where supercooled water freezes in layers, and the stronger the updraft, the longer a stone can stay aloft, growing bigger with each trip through the freezing zone, until it finally gets too heavy for even that violent rising air to hold. Then it falls. A stone that size hits the ground at speeds that can exceed 100 miles an hour. It shatters windshields. It punches through vinyl siding. It dents metal roofs and totals cars sitting in driveways. And if it catches a person or an animal in the open, it causes serious injury. The exceptional instability we discussed, that 2,000 to 3,000 joules per kilogram of fuel, is precisely what builds updrafts strong enough to grow hail this large. The same energy that makes the tornado possible makes the ice possible. Then there is the wind. The forecast warns of damaging straight-line winds with isolated gusts over 75 miles an hour. I want to be precise about that number, because people hear wind and think of an unpleasant but survivable gust. 75 miles an hour is hurricane force. It is the threshold at which a tropical storm officially becomes a hurricane. A gust like that, driven down out of a storm as a downburst or racing along the leading edge of a bowing line, is fully capable of snapping mature pine trees, and in a heavily forested region like northern New England, that matters enormously. Falling trees are one of the leading causes of death and property destruction in wind events, and they are what take down power lines. A wind like that can knock out electricity for thousands of people, block roads with timber, and turn a wooded property into a field of hazards in a matter of minutes. This is the threat that is expected to broaden later in the evening, as the storms merge into that wall of wind and race southeast into the dark. And then, sitting above and beyond both of those, is the tornado. A tornado in an environment like today's, with this much fuel and this much shear, is not the weak, brief spin-up that New England occasionally sees. The concern spelled out in the forecast is for the possibility of a strong tornado, meaning one capable of significant life-threatening damage. In the language of the rating scale, that is the difference between a storm that peels shingles and one that removes roofs, throws vehicles, and levels well-built structures. The reason the professionals use the word strong is that the ingredients support it. When a rotating supercell taps into this kind of instability and shear, the rotation can tighten and reach the ground with genuine force. It is rare here. That is the entire point. But rare is not the same as impossible, and today the atmosphere has assembled the conditions where it becomes possible. Here is why all three of these threats matter more than they would somewhere else, and it comes straight back to the pattern that built them. This is a region without the infrastructure of caution that Tornado Alley has spent generations developing. In Oklahoma, there are storm shelters, tornado drills in schools, a population that knows the difference between a watch and a warning, and knows where to go when the siren sounds. In the northern forests of Maine and New Hampshire, much of that simply does not exist, because it has never needed to. And that gap in preparation is not the atmosphere's fault. It is a direct result of the fact that the pattern delivering these storms almost never comes here. The rarity that makes today remarkable is the same rarity that makes today dangerous. A place is least ready for the disaster it has never had to face. Let me give you the scale that forecasters actually use to rate a tornado's damage, because it makes the word strong concrete. It is called the Enhanced Fujita scale, and it runs from EF0 at the bottom to EF5 at the top. An EF0 or EF1 tornado, the weak category, peels shingles, snaps branches, and tips over the occasional weak structure, with winds up to around 110 miles an hour. A strong tornado, meaning EF2 or higher, begins around 111 miles an hour and climbs from there, and at that level the damage changes in kind, not just degree. Roofs come off well-built houses, mobile homes are destroyed completely, large trees are snapped or uprooted, cars are lifted and thrown. When the forecast raises the possibility of a strong tornado, that EF2 and up range is what it means, and it is a category that northern New England sees only very rarely. The rating is assigned after the fact, by surveying the damage, but the environment today is one that could support it, which is exactly why the word appears in the outlook. The straight-line wind threat deserves its own mechanism because people often assume the only dangerous wind in a storm is a tornado, and that is not true. A downburst is a violent column of air that a storm drives straight down toward the ground, where it hits and spreads out in all directions, and it can produce winds every bit as destructive as a weak to moderate tornado just without the rotation. When these downbursts line up along the leading edge of a bowing line of storms, the result is a long, continuous swath of damaging wind that can stretch for tens or even hundreds of miles, which is how a single storm complex can knock out power across an entire region in one pass. That is the threat expected to broaden across New England later tonight, and in a densely forested region it translates directly into downed trees, blocked roads, and widespread outages. I want to be careful and fair here, the way this channel always tries to be. Everything I have just described is what the storms are capable of, not a guarantee of what they will do. The forecast lists these hazards as possible and, in the case of the strongest ones, isolated, meaning they are not expected everywhere, but rather in a few of the most intense cells. Most people inside the risk zone tonight will experience a strong thunderstorm, heavy rain, gusty wind, and nothing worse. The danger is real, but it is not universal, and the responsible way to hold it is to respect it without being paralyzed by it. Know the threat, have a way to be warned, know where you would shelter, and then get on with your evening. But respect it we should, because the combination is unusual, and the timing is unkind. Baseball-sized ice, hurricane-force wind, and the possibility of a strong tornado, all delivered after dark into a region that has no muscle memory for any of it, by a pattern that almost never visits. That last piece, the lack of muscle memory, is worth its own hard look, because it is the difference between a storm that becomes a story and a storm that becomes a tragedy. And it connects, in an uncomfortable way, to a piece of New England history that keeps coming up whenever meteorologists look at a setup like this one. There is a reason older forecasters in the northeast get a specific look on their faces when the northwest flow lines up like this, and it has a date attached to it. Part 6. The region that has no muscle. Memory for this. Ask a long-time forecaster in the northeast what worries them about a setup like today's, and many of them will reach for the same memory. It happened in the middle of July, roughly 30 years ago, on July 15th of 1995. A fast-moving complex of storms, born of a northwest flow pattern much like the one overhead right now, swept down out of Canada and across the Adirondack region of northern New York in the pre-dawn and morning hours. It was not a tornado. It was a derecho, a vast, long-lived wall of straight-line wind, and it did something the region had almost no framework for. It flattened the forest. Across enormous stretches of the Adirondack wilderness, millions of trees were snapped or uprooted in a matter of minutes. Several people were killed, many of them campers caught in the open under falling timber. It became known as the Great Blowdown, and it lives in the memory of northeastern meteorology as the example of what a northwest flow event can do to this part of the country when everything aligns. I bring it up not to say today will be that, because it may well not be, but to explain why experienced forecasters take a setup like this seriously rather than dismissing it as too far north to matter. The lesson of 1995 is that this region is not immune. The same geometry we have been describing, storms sledding down the top of a ridge on a fast northwest wind, has produced genuine catastrophe here before. It is uncommon. It is not unprecedented. And uncommon but not unprecedented is exactly the category that catches people off guard, because it falls into the gap between what they expect and what they prepare for. That gap is the real vulnerability today, and it is worth naming plainly. Northern New England is one of the least tornado experience populated regions in the country. That shapes everything about how a severe event plays out here. Consider the housing. The region has a significant number of older homes without basements, and a meaningful number of mobile and manufactured homes, which are among the most dangerous places to be in a tornado or a severe wind event. A mobile home offers almost no protection against strong winds, and the standard safety advice, to get out and get to a sturdy shelter before the storm arrives, depends on knowing the storm is coming with enough lead time to act. Which brings us to the second vulnerability. The warning culture is thinner here. In the plains, the entire society is wired for this. Sirens, shelters, school drills, a public that has internalized the difference between a tornado watch, which means conditions are favorable, and a tornado warning, which means one has been detected and you need to move now. In the northern forests of New England, that wiring is sparse, because the threat has been so rare that building all of it was never a priority. So you have homes that offer little protection, a public without deep practice, and as we covered, a threat arriving after dark when people are asleep and cannot see it coming. Each of those factors multiplies the others, and every one of those vulnerabilities traces back again to the same root. This region is unprepared precisely because the pattern that threatens it today almost never arrives. You do not build a tornado culture for a threat you get once in a generation. The rarity is not a reassurance, it is the source of the danger. The places most likely to be hurt by a weather event are not always the places that get the worst weather. Often they are the places that get bad weather so seldom that they never learn to expect it. Today, the northern edge of that anchored dome is pointing its most organised storms at exactly such a place. And 1995 is not the only entry in New England's uneasy tornado history. Go back to June 9th of 1953, and you find one of the deadliest tornadoes in the entire recorded history of the Northeast, the Worcester tornado in central Massachusetts. It carved a long track across the region and killed on the order of 90 people, an almost unthinkable toll for a place that thinks of itself as safe from such things. More recently, on June 1st of 2011, a strong tornado tore through Springfield, Massachusetts and surrounding towns in broad daylight, killing several people and stunning a region that simply did not believe it could happen there. Each of these events shares the same lesson. The Northeast is not immune, and the danger is amplified precisely because the public does not expect it. A tornado that would trigger an immediate practiced response in Kansas can catch a New England community standing at the window, watching, because the possibility is not part of the local imagination. The housing vulnerability is worth putting a finer point on because it is one of the clearest predictors of who gets hurt. Nationally, a hugely disproportionate share of tornado deaths occur in mobile and manufactured homes. Despite those homes housing only a modest fraction of the population, the physics is unforgiving. A manufactured home, even a well-anchored one, simply cannot withstand the winds of a strong tornado or a significant downburst, and it can be rolled or destroyed at wind speeds that a conventional home would survive. In a rural region like northern New England, where manufactured homes are common and the nearest sturdy shelter may be miles away, that vulnerability is acute, and it is the single biggest reason the safety advice for tonight emphasizes knowing, in advance, where you would go. This is also where the human scale of this becomes real, and where the connection to the rest of the day comes into focus. The forecast is not describing an abstraction over an empty forest. It is describing a threat to families in small towns, strung along the northern borders of New York, Vermont, New Hampshire, and Maine. People who are going about an ordinary hot July evening with, for many of them, no deep instinct that tonight is different. Getting a message like this in front of them, that the sky tonight is loaded in a way it rarely is, that the dangerous hours are after dark, and that they should have a way to be woken by a warning, is genuinely the difference between a near miss and a disaster. There is a specific piece of advice that matters more here than almost anywhere else, and it is this. Do not rely on seeing or hearing the storm. Have a way to be warned that will reach you even while you sleep. A weather radio or emergency alerts enabled on your phone, so that if a warning is issued for your exact location in the middle of the night, something wakes you. In a region without sirens, without shelters, without the reflexes that the planes take for granted, that single piece of technology, an alert that pierces sleep, may be the most important line of defense there is. Because the storms that come out of a night like this do not announce themselves the way daytime storms do. The first sign, for someone asleep in a house in the northern woods, may be the sound of the wind already at the door. So that is the north edge of the dome in full. A rare and dangerous alignment of fuel and shear, a pattern tilted the wrong way, storms aimed at the forest after dark, and a population with no muscle memory to fall back on, all of it built by a single feature parked over the middle of the country. But a seesaw has two ends. Everything we have just described is what that dome is doing on its northern flank. To understand why today is the kind of day forecasters rarely ever see, we have to travel to the other end of the pattern, 1,000 miles to the south, where the very same system is producing a disaster that is its complete opposite in every way but one. It is just as dangerous, and it is driven by the same dome. Part 7. 1,000 miles. South, the same storm. Leave the dark forests of Maine for a moment and drop down to the dry, rocky country of south-central Texas, and you would swear you had arrived on a different planet, in a different season, under a different sky. Where northern New England is bracing for a few violent hours of wind and rotation, this land is already underwater, and it is not going to stop for days. And yet, and this is the part that should stop you, it is the same storm, the same dome. The very feature-building tornado fuel over Quebec is, at its other end, wringing catastrophic rain out of the Gulf of Mexico and dropping it on Texas. Two disasters that could not look more different, born of one pattern. Let me give you the ground truth first, because this is not a forecast of something that might happen. It is already happening. In Terrell County, in the remote country of southwest Texas, emergency management has reported significant flash flooding, with roads and low water crossings underwater. The measured rainfall there is 8 to 10 inches since the previous day. 8 to 10 inches. To picture what that means, understand that many of these areas would consider a foot of rain a substantial fraction of what they might expect in an entire year, and it has fallen in roughly a day. Flash flood warnings have been issued across portions of Pecos and Terrell counties, where radar has been showing storms parked over the same ground, dropping heavy rain hour after hour. In Pecos County, totals of 2 to 4 inches, with locally over 5, had already fallen. The water is on the ground right now and the storms are not finished. The reason this is a genuine emergency and not just a very wet day comes down to how this land handles water, and I will get deep into that shortly. For now, hold the human reality of it. A flash flood is not the slow, creeping rise of a river over hours that gives people time to gather their things and leave. It is a wall of water that can appear in minutes, turning a dry creek bed or a quiet roadway crossing into a fast, deep, deadly current before anyone has time to react. It is the reason the single most repeated piece of safety advice in Texas flood country is turn around, do not drown, because more people die in flash floods trying to drive across flooded roads than almost any other way. It only takes a foot or two of moving water to lift a vehicle and carry it off, and the pattern setting this up is engineered, physically, to keep the water coming. Here is the mechanism, and here is where it ties straight back to the dome. On the northern edge of that ridge, we have the fast, dry northwest wind sledding storms into Maine. On the southern and western edge, the circulation around the high is doing the opposite. It is drawing a deep river of tropical moisture up out of the Gulf of Mexico and steering it inland over Texas. And sitting nearby, over the Mississippi Valley, is a slow-moving pool of low pressure in the upper atmosphere that is refusing to move things along. So you have an endless supply of Gulf moisture being fed in, and nothing to sweep the storms away. The result is storms that form, rain themselves out over one spot, and are immediately replaced by new storms forming in the same place. The atmosphere has built a machine for dropping rain on the same ground over and over, and it will not shut off on its own. This is the seesaw made real. I keep returning to that image because it is the truest way to understand today. Push down on the north edge of the dome and you get a dry, violent, fast-moving few hours of wind and rotation over New England. Push down on the south edge and you get a wet, relentless, days-long siege of flooding over Texas. Same pivot, same dome, opposite ends. The storms in Maine will be over by tomorrow. The water in Texas is a multi-day event that is only beginning. One pattern, operating at both extremes of what an atmosphere can do, at the same time, with millions of people living at both ends of it. The official forecast for what is still to come is sobering. The Weather Prediction Center, the national office responsible for rainfall forecasting, expects repeated rounds of storms from the Texas Hill Country into the Big Bend region through Thursday, with widespread storm totals of 6 to 8 inches and localized amounts above 10 inches. And here is the detail that should raise the hair on your neck. Terrell County has already measured 8 to 10 inches, which means it has already reached the upper end of the multi-day regional forecast before the multi-day event is even over. When the ground has already absorbed the amount of rain that was supposed to represent the worst case for the whole episode, and the rain is still falling, the realistic ceiling for the hardest hit spots climbs higher than the official numbers suggest. The forecasters know this, which is why the language around this event is so heavy. Let me put a number on just how loaded the air over Texas is right now, because it is the mirror image of the fuel we discussed over Maine. Meteorologists measure the total amount of water vapor in a column of the atmosphere as precipitable water, essentially how much rain you would get if you wrung out every drop of moisture in the air above a single spot. During events like this, when a deep tropical connection to the Gulf is established, precipitable water values surge to levels near the highest the region ever records, meaning the atmosphere is nearly saturated, primed to rain with brutal efficiency. When air that wet gets lifted, it does not produce a gentle drizzle. It produces rainfall rates of 2, 3, even 4 inches per hour in the heavier cells, the kind of intensity that overwhelms any drainage in minutes. That is the raw material the dome is feeding into Texas, and it is why the totals climb so fast. The role of that upper-level low over the Mississippi Valley is worth understanding too, because it is the piece that removes the atmosphere's natural off-switch. Normally, storms are swept along and eventually pushed out of a region by the broader flow. But a slow, cut-off pool of low pressure aloft does the opposite. It sits there, spinning gently, providing just enough lift and just enough of a focus to keep triggering new storms while doing nothing to move the old ones out. Combine that stalled trigger with the endless Gulf moisture feed, and you have removed both the limits on how much rain can fall. There is no shortage of water, and there is no mechanism to make the storms leave. That is the recipe for a rainfall disaster, and it is exactly what is in place. There is one more reason this particular corner of Texas makes meteorologists nervous, and it is not only about the rain. It is about what this land does with rain once it arrives, and about the rivers that thread through it. Because the hill country is not flat, absorbent farmland. It is rock and canyon and steep terrain, laced with rivers that can rise from a trickle to a torrent faster than almost anywhere in the country. That combination of geography and geology is what has, in the past, turned rain events in this exact region into some of the deadliest flash floods in American history. To understand why today's totals are so dangerous, and why the same dome that threatens Maine with wind threatens Texas with something far more sustained, you have to understand the ground itself, and that ground has a grim reputation. Part 8. The Rock That Cannot Drink. There is a stretch of Texas that hydrologists have quietly given one of the most alarming nicknames in American geography. They call it Flash Flood Alley. It runs roughly along a geological feature called the Balcones Escarpment, a line where the flat coastal plains rise up into the higher, rockier country of the hill country and the Edwards Plateau, and it is, by several measures, one of the most flash flood-prone regions in all of North America. The rain falling there right now is not falling on forgiving ground. It is falling on some of the most dangerous flooding terrain on the continent, and understanding why is the key to understanding why 8 to 10 inches here is a very different thing than 8 to 10 inches somewhere else. Start with the rock. Much of the hill country is thin soil over hard limestone. When rain hits ground like that, the ground cannot drink it. In deep, absorbent farmland, a heavy rain soaks in, and the soil acts like a sponge that buffers the flood. On thin soil over rock, the water has nowhere to go but sideways and down, running off almost instantly, sheeting across the surface and pouring into the creeks and canyons. Then add the shape of the land. The hill country is steep and folded, cut by countless dry creek beds and narrow river valleys. Those valleys act like funnels. Rain that falls across a wide area of high ground all drains, fast, into the same low channels, and the water piles up as it converges. A creek that was a dry ribbon of gravel in the morning can become a wall of brown water taller than a person by the afternoon, moving fast enough to carry away vehicles, livestock, and homes. This is not hypothetical. It is the documented history of this exact region, which has produced some of the deadliest flash floods the country has ever recorded. Now lay the weather pattern on top of that geography, because the two are combining in the worst possible way. Remember the machine we described, the endless Gulf moisture feeding in on the south side of the dome, and the slow upper-level low nearby refusing to move things along. That is producing what meteorologists call training storms, and the name is exact. Picture the cars of a freight train passing a single point on the tracks. Each car is a separate thunderstorm, but they all follow the same path over the same ground, one after another after another. When the low-level winds carrying the storms and the steering winds up above are aligned, a storm forms, moves along the line while raining hard, and is immediately replaced by a new storm forming at the same starting point, which then follows the identical path. To a person standing underneath, it feels like one storm that simply will not end, but it is really a procession, and the total rainfall over that one spot climbs relentlessly, because the spigot never moves off it. Training storms are the signature of the deadliest flash floods, and the reason is simple arithmetic. It is not the intensity of any single storm that overwhelms the land. It is the repetition. One storm dropping 2 inches is a nuisance. 10 storms each dropping 2 inches over the same watershed, over many hours, is a catastrophe, because the ground and the creeks never get a chance to recover between them. And that is precisely the pattern parked over the hill country right now, with the forecast calling for repeated rounds through Thursday. The atmosphere has aimed a conveyor belt of rain at some of the least absorbent, most efficiently draining terrain in the country and set it to run for days. This region's reputation is not a matter of opinion. It is written in a long and painful record of disaster. The hill country and the broader flash flood alley have produced some of the deadliest floods in the history of the United States, again and again, across generations. Rivers like the Guadalupe have a documented history of rising many feet in a matter of hours, transforming from peaceful summer streams into destructive torrents. The region has seen catastrophic floods in the 1980s and again in the following decades, and just last summer, in July of 2025, a devastating flood tore down the Guadalupe River corridor in the pre-dawn hours and took a heartbreaking toll, including at a children's summer camp, in one of the worst flood disasters the state has endured in living memory. I raise it not to sensationalize a wound that is still raw for so many families, but because it is the essential context for why forecasters and residents in this part of Texas treat a setup like today's with such gravity. They have seen what this land does with too much rain, too fast in the dark. The memory is close, and the caution it demands is earned. That history is exactly why the language around today's event is so serious, and why the safety messaging is so blunt. When you combine terrain with a proven capacity for lethal flooding, a rainfall pattern designed to run for days, and antecedent conditions that speed runoff, you have every ingredient that has produced tragedy here before. None of that guarantees catastrophe today, but it explains why no one in a position of responsibility is treating this casually, and why the honest thing to do is to take it as seriously as the people who live there do. I want to keep tying this back to the north edge of the dome, because the connection is the entire reason this video exists. The same organising feature that gives northern New England a fast, dry, violent northwest wind is what gives Texas a slow, wet, stalled flow that traps storms in place. It is not that two different weather systems happen to produce two different disasters. It is that one dome, by its very shape, drives dry violence off one flank and wet catastrophe off the other. The tornado threat over Maine and the training storms over the hill country are the same physics viewed from opposite sides. When you understand the pattern, the two stories collapse into one. There is a bitter irony hiding in this Texas ground too, and it connects to another thread of today's weather that we'll get to. This region has spent much of the recent past in drought, its soil baked hard and dry. You might think dry ground would help absorb a heavy rain, but with terrain like this, the opposite is often true. Sun-baked soil over rock can become almost water-repellent, so the first heavy rain runs off even faster than it would on moist ground, like water beading off a dry, hard-packed surface. So the same broad pattern of heat and drought that has dried this land out has, in a cruel twist, primed it to shed today's rain straight into the creeks. The dome does not only deliver the rain, it helped prepare the ground to flood. So we have the rock that cannot drink, the funneling valleys, and the conveyor belt of storms set to run for days over one of the most flood-prone landscapes on the continent. That is the setup. What it produces, in practical terms, is rising water in specific rivers with specific names and forecasts that have already been upgraded as the situation worsens. To see how close this is getting to genuine disaster, and to be honest about the uncertainty that still remains, we need to look at the rivers themselves and at the exact language the National Weather Service is using as the water climbs. Part 9. The rivers are already being named. When the National Weather Service starts issuing flood warnings for individual rivers by name, the abstract threat of heavy rain has become a specific, located danger, and today the list of named rivers in south-central Texas is growing. Let me walk you through them, because each one tells you something about how this event is unfolding and how the professionals are watching it climb. Start with the Nueces River. The office in Austin and San Antonio has issued flood warnings for the Nueces at Laguna and for the Nueces below Uvalde, both in Uvalde County. The forecast there is for minor flooding, but the impact statements attached to those warnings describe how conditions turn worse at higher stages, with water overflowing the banks of recreation camps and cutting off access. Then there is the Devil's River, out in Val Verde County, near the Mexican border, with warnings issued at Cawthorn Ranch near Juneau and at Baker's Crossing north of Comstock, again for minor flooding with low crossings expected to go underwater. And further east, the Tres Palacios River near Midfield, in Wharton and Matagorda counties, where the forecast was actually upgraded, changed from minor to moderate flooding as the outlook worsened. On top of all of that, the office in Corpus Christi has posted a flood watch stretching for days. The rivers are being named one after another, and at least one has already been bumped up in severity. I want to be careful and precise about these river forecasts, because precision is where honesty lives. Several of these warnings are for minor flooding, which is the lowest official category, the kind that floods low crossings and yards rather than destroying homes. It would be dishonest to describe every one of these rivers as a catastrophe in progress. But two things make this more serious than the word minor suggests. First, the impact statements repeatedly note that at higher stages, the flooding becomes moderate, with real consequences, and the rain is still falling, which means these gauges are forecast to keep rising. Second, the flash flooding that kills people in this region often is not the big named river at all. It is the small creek, the low water crossing, the dry wash that no gauge is watching, that goes from empty to deadly in minutes. The named rivers are the part of the danger we can measure. The unmeasured creeks are the part that has historically done the killing. It helps to understand what those official flood categories actually mean, because the words carry precise thresholds. The National Weather Service rates river flooding in tiers. Minor flooding means minimal impacts, some low-lying roads and fields underwater, the kind of thing that is a nuisance and a hazard, but not usually a threat to homes. Moderate flooding means some structures and roads near the river are affected, and some evacuations may be needed. Major flooding means extensive inundation, serious threats to life and property, and the kind of scenes that make the national news. Today, the forecasts on these South Texas rivers mostly sit at minor, with the Tres Palacios already bumped up to moderate, and the key phrase running through all of them is that impacts worsen at higher stages. In other words, these are forecasts of where the rivers are expected to crest given current information, and with rain still falling, the direction of risk is upward. A river forecast is a moving target during an active event, and every one of these gauges is being watched in real time as the totals climb. The distinction between river flooding and flash flooding matters here too, and it is a distinction that costs lives when people miss it. River flooding is the slow kind, where a river gauge climbs over hours or days, and forecasters can tell you roughly when and how high it will crest. Flash flooding is the fast kind, where intense rain overwhelms a small creek or a road crossing in minutes, with little or no warning from any gauge. Today's setup threatens both at once, and it is the flash component, the ungauged creek and the flooded crossing, that demands the most immediate caution from anyone in the area. This is why the single most important safety message out of Texas today is so blunt, and why it is worth repeating even though you have probably heard it before. Turn around, do not drown. The overwhelming majority of flash flood deaths happen in vehicles when a driver encounters a flooded roadway and decides to cross it, misjudging the depth and the speed of the water. It takes only about a foot of moving water to float a car, and about 2 feet to carry away most vehicles, including large ones. The water is often moving faster than it looks, and the roadbed underneath may already be washed out, so what appears to be a shallow crossing can be a deep, fast channel over nothing. In a multi-day event like this one, with the roads flooding after dark across a wide region, that single decision, whether to turn around or to try it, is the decision most likely to determine who survives. No destination is worth it. The water will recede. Wait for it. Now let me connect this back to the pattern one more time, because the multi-day nature of the Texas flood is itself a fingerprint of the dome. A normal flash flood is a few hours of intense rain and then it is over, the system moves on. What makes this one so dangerous is that the pattern is stuck. The dome is anchored, the Gulf moisture keeps feeding in, the upper level low keeps the storms from clearing out, and so the event does not have a natural end the way a passing front would give it. The rain is forecast to keep redeveloping over the same ground through Thursday, and some data suggests it could linger even beyond that. This is the same stalled quality that, on the dome's north side, schedules Maine storms for the dangerous overnight hours. A stuck pattern is dangerous everywhere it touches, just in different ways. In New England, it concentrates violence into a single dark evening. In Texas, it stretches a flood across days, And I have to be honest about the uncertainty here, the same way I was honest about Maine, because the two ends of this pattern share that too. The exact totals in Texas are not locked in. Forecasters have noted that the highest local amounts depend on precisely where the training storm set up, and a shift of even 10 or 20 miles could mean the difference between a hard-hit rural county and a hard-hit city. Some of the higher resolution computer models have suggested that certain spots could see rainfall well beyond the official numbers, while the broader, smoother models keep the totals more contained. The truth is that a training storm event like this is one of the hardest things in all of meteorology to pin down in advance, because so much depends on small-scale details that the models genuinely cannot resolve until the storms are actually forming. What is certain is the ingredients and the setup. What is uncertain is exactly where the worst of it lands. That is precisely the kind of honesty this situation demands, and it is the kind ordinary coverage often skips. So that is the south edge of the dome, laid out in full. Rain already on the ground, rivers being named and upgraded, some of the most flood-prone terrain on the continent, a conveyor belt of storms set to run for days, and a genuine, honestly stated uncertainty about just how bad the worst spots will get. But we have now described both ends of the seesaw without ever fully examining the pivot in the middle, the thing that makes both ends move. It is time to look directly at the dome itself, the anchored ridge of high pressure that is the engine behind every single thing we have discussed, because it is not just steering these disasters, it is also, in its own right, breaking records. Part 10. The Boulder in the River. We have talked around the dome for this entire video, describing what it does to its north and what it does to its south, but now I want to put it directly in the centre of the frame, because it is the single object that explains the whole day. Meteorologists have a favourite way of describing a blocking ridge like this one. Imagine a fast river, and imagine dropping an enormous boulder into the middle of it. The water cannot flow through the boulder. It has to split and go around, racing along both sides, curling and accelerating around the edges. The atmosphere over the United States right now has a boulder in it, a vast mound of hot, high-pressure air anchored over the centre of the country, and the jet stream is that river, forced to split and race around it. Everything violent happening today is happening on the edges of that boulder, where the flow is bending and accelerating. The Maine storms ride one edge, the Texas moisture rides another. The dome is the pivot for all of it. But the dome is not only a steering mechanism for other people's weather. Directly beneath it, it is producing a hazard of its own, and it is a serious one. Under a strong ridge, the air sinks, and sinking air warms and dries and clears the sky, which is exactly the recipe for extreme heat. And that is what is unfolding across the northern plains and the upper Midwest right now, with temperatures forecast between 95 and 105 degrees, hot enough that daily records are expected to fall. The heat does not stay put either. As the dome shifts eastward, its warmth spreads. The upper 90s are pushing into New England, and the mid-Atlantic could reach a full 100 degrees on Wednesday. Down in South Florida, heat indices, which measure what the temperature actually feels like once you factor in the humidity, are forecast between 105 and 110 degrees. In central Illinois, heat indices in the upper 90s to low 100s today are expected to climb even higher, into the range of 98 to 103 degrees, and stay there through Saturday. This is a broad, dangerous, record-challenging heat event in its own right, and it is the same dome. I want to make sure the deadliness of heat lands, because it is the quietest of today's hazards and historically the most lethal. Heat kills more people in the United States in a typical year than tornadoes, floods and hurricanes combined. It does not look dramatic. There is no roar, no wall of water, no funnel on the horizon. It is just a temperature, and that is exactly what makes it so dangerous. People underestimate it. The greatest risk comes when the heat does not break at night, when the overnight low stays so high that the body never gets its chance to cool down and recover, and the physiological stress simply accumulates day after day. Under a locked dome like this one, with warm, humid nights, that is precisely the danger. The extreme heat warnings and advisories stretched across the northern tier of the country today are not bureaucratic caution. They are a response to a genuine killer, working silently under the same ridge that is throwing storms at Maine and rain at Texas. Let me explain the sinking air mechanism a little more, because it is what physically links the heat to everything else the dome does. Inside a strong high-pressure ridge, air is gently descending over a vast area. As air sinks, it is compressed by the higher pressure lower down, and compression warms it, the same way a bicycle pump gets warm as you compress the air inside it. That descending, warming air also dries out, because its capacity to hold moisture rises as it warms, which is why ridges bring clear, cloudless skies. Clear skies then let the sun hammer the surface unimpeded, adding even more heat. It is a self-reinforcing furnace. Sinking air warms the column, clear skies let the sun bake the ground, and the ground radiates that heat back into an already warm air mass that has nowhere to go. That is how a dome manufactures record temperatures out of ordinary summer sunshine, and it is why the hottest, driest, most fire-prone conditions sit directly under the ridge while the violent weather rides its edges. The human body's limits in this kind of heat are worth stating plainly, because they are not infinitely flexible. The body cools itself primarily by sweating, and sweat works by evaporating off the skin. But when the air is both hot and humid, sweat evaporates poorly, and the cooling system starts to fail. Meteorologists capture this with the heat index, the combination of temperature and humidity that tells you what the air actually does to a body. And today's heat index values, from the 105 to 110 degree range in South Florida to the upper 90s and low 100s across the middle of the country, are in territory where prolonged exposure becomes genuinely dangerous, especially for the elderly, the very young, and anyone working or exercising outdoors. Heat is a physiological threat, not just a discomfort, and the dome is delivering it to a huge swathe of the country at once. Here is the unifying picture, the thing I most want you to carry out of this video. One feature, three faces. Directly beneath the dome, deadly heat. On its northern edge, a rare, severe and tornado threat. On its southern edge, a catastrophic multi-day flood. These are not three stories. They are one object, seen from three sides. A person in Bismarck baking in triple-digit heat, a person in northern Maine watching the sky after dark, and a person in the Texas hill country watching a creek rise are all, in a very real sense, experiencing the same weather. They are standing at three different points on the same dome. That is what makes today the kind of day forecasters rarely ever see, and it is why the honest way to tell it is as one connected story rather than a scattered list of separate warnings. And it raises the question that sits underneath this entire channel. Why do these locked, two-faced patterns seem to be showing up so often lately? Why does it feel like every few weeks there is another stuck dome, another stalled block, another single pattern producing opposite extremes across the country at once? Part of the answer is simply that these patterns have always existed. Blocking ridges are a normal, well-understood feature of the atmosphere, and dramatic simultaneous weather is not new. But part of the answer is more unsettling, and it involves the state of the ocean and the temperature of the baseline that all of this weather is now building on top of. Because the dome is not forming over the same planet it would have a few decades ago. It is forming over a warmer one, and that changes what it is capable of. Before we get there, though, I want to close the loop on the dome's reach, because we have covered its north edge, its south edge, and its scorching centre. But there is a fourth face we have not yet examined. Off the dome's dry western flank, the same sinking, drying, superheated air that is breaking temperature records is doing something else. Something that has been building all summer across the mountains and high deserts of the interior west. The heat that makes the records is the same heat that primes the land to burn, and right now that western flank is on fire. Part 11. The fire on the dome's western edge. The same sinking, drying air that is breaking temperature records under the dome has a fourth consequence, out on the ridge's western flank, and it has been smouldering all summer. Across the interior west, large wildfires are burning right now, and they are burning in the hot, dry, wind-prone conditions that a locked ridge creates. This is not a separate weather story either. It is the dome's dry face, the mirror image of the wet face drowning Texas. Consider the scale of what is already active. In Utah, the Babylon fire has burned more than 106,000 acres and is only about half contained. Also in Utah, the Cottonwood fire has consumed over 97,000 acres. In Colorado, the Aspen Acres fire has burned nearly 99,000 acres at about a third contained. The Ferris fire has passed 64,000 acres, and the Gold Mountain fire at over 36,000 acres is barely 12% contained. These are enormous fires, and the conditions today are not helping. Forecasters have flagged elevated fire weather across parts of the west, the combination of gusty wind and very low humidity that lets a fire run, and there is even a threat of isolated dry thunderstorms, storms that produce lightning but little rain, which is one of the most efficient ways nature has of starting brand new fires in country that is ready to burn. The reason this connects to everything else is the drought underneath it. Across the continental United States, roughly 2/3 of the country is in some level of abnormal dryness or drought, with nearly 30% in severe drought or worse. That parched landscape is the fuel bed, and the dome's heat is the accelerant. The hotter and drier the air, the faster vegetation dries out, and the more explosively it burns when a spark finds it. So the western fires are not a coincidence sitting next to the heat. They are a product of it. The dome bakes the land dries to tinder, and the fire weather on the ridge's edge does the rest. The dry thunderstorm threat flagged for today deserves a closer look, because it is one of the most efficient fire-starting mechanisms in nature, and it sounds like a contradiction until you understand it. In very dry air, a thunderstorm can form high up and produce lightning, but the rain it drops evaporates before it ever reaches the ground, a phenomenon called virga. So you get the spark, thousands of lightning strikes, without the water that would normally put out any fire they start. Lightning igniting bone-dry vegetation, with gusty outflow winds from the same storms fanning the flames, is exactly how enormous wildfires begin in the interior West, and it is why forecasters treat an isolated dry thunderstorm threat over drought-stricken land as seriously as they do. One storm that produces no meaningful rain can start a dozen new fires in an afternoon. The drought numbers underneath all of this are worth stating precisely, because they define how ready the land is to burn. Across the continental United States, roughly 67% of the country is in at least abnormally dry conditions. Nearly 47% is in moderate drought or worse, and just under 30% is in severe drought or worse, with a small but serious fraction, around 1%, in the most extreme category the monitor tracks. Those are not just statistics. They are a measure of how much of the country's vegetation has been dried into fuel. And the fires already burning show what happens when that fuel meets heat and wind. A fire like the Babylon Fire in Utah, at over 106,000 acres, is not a brush fire. It is a landscape-scale event, and the fact that several fires of that magnitude are burning simultaneously across the interior West is itself a signature of just how primed that region has become. I want to tie this fourth face back to the whole, because it completes the picture of just how much one pattern is doing. Think about the reach of this single dome. Under its centre, record heat. On its northern edge, a rare tornado threat over New England. On its southern edge, a catastrophic flood over Texas. And on its western flank, wildfires running through drought-dried country under gusty, bone-dry wind. Heat, wind, water, and fire. The four classical faces of a violent atmosphere, all being driven at the same moment by the same feature. It is genuinely rare to be able to draw a line from a fire in Utah to a flood in Texas to a tornado threat in Maine, and have that line be a real, physical thing rather than a rhetorical flourish. But today, the line is real, and it runs straight through the dome. There is a cruel symmetry between the western fires and the Texas floods that is worth pausing on, because it shows how the same underlying condition can produce opposite disasters. Both regions have been shaped by drought. Out west, the drought has dried the forests and grasslands into fuel, so the danger is fire. In Texas, as we discussed, the drought baked the soil hard, so when the dome's moisture finally arrived, the danger became flood, because the ground shed the water instead of absorbing it. Same dry starting condition. Opposite catastrophes, decided entirely by which face of the dome you happen to be standing under. Dry land burns on one flank and drowns on another. That is the kind of thing that sounds like a contradiction until you understand the pattern, and then it makes perfect, unsettling sense. So the western fires are the fourth confirmation of the thesis. This is not a week of unrelated disasters. It is one anchored ridge showing you the full range of what it can do, from the driest extreme to the wettest, across thousands of miles all at once, And that brings us back to the question I raised a moment ago, the one that sits underneath this whole channel. Patterns like this have always existed, so why does it feel like they keep happening, keep locking in, keep producing these simultaneous opposite extremes? To answer that honestly, we have to look at the stage all of this weather is now performing on, the temperature of the oceans and the state of the climate baseline, because the dome is not forming over the planet of a few decades ago. It is forming over a warmer one, and a warmer baseline does specific, measurable things to what a stuck pattern is capable of. Part 12. Why the rare keeps becoming routine. Here is a number that puts today in a much larger frame. There is a measure oceanographers use to track the state of the tropical Pacific called the Oceanic Niño Index. When it is strongly negative, we are in La Niña. When it's strongly positive, we are in El Niño. Just a couple of seasons ago, this index was sitting at negative 0.54, firmly in La Niña territory. The most recent reading has it at positive 0.98, well into El Niño. That is a swing of more than 1.5 degrees in the index in roughly 2 seasons, an unusually fast flip from one state of the Pacific to its opposite. The planet's largest ocean has changed its mood in a hurry, and that matters for weather everywhere, because the Pacific is the single biggest lever on the global atmosphere. El Niño, in the simplest terms, is a warming of the central and eastern tropical Pacific that releases an enormous amount of heat and moisture into the atmosphere and reshuffles the jet stream in ways that ripple across the entire globe. It tilts the odds towards certain patterns and away from others, and it tends to make the atmosphere more energetic. But El Niño is only part of what is going on, and honestly the more important part is quieter and more permanent. This El Niño is switching on over an ocean that was already running warm, warmer than the historical baseline, part of a long-term rise in ocean heat. And that warmed baseline is the thing that quietly changes the rules for every weather pattern that forms on top of it. The mechanism is one of the most solid pieces of physics in all of atmospheric science, and it has a name that sounds intimidating but describes something simple. It is called the Clausius-Clapeyron relationship, and what it says is this: warmer air can hold more water vapor. Specifically, for every 1 degree Celsius the air warms, it can hold roughly 7% more moisture. That is not a theory or a projection. It is measurable, repeatable physics you could demonstrate in a laboratory, and it has an enormous consequence for days like today. When the atmosphere is warmer, there is more water vapor available to be wrung out as rain, which means the heaviest downpours can be heavier. There is more latent heat energy stored in that humid air, which means storms have more fuel. The dice have not been replaced, but they have been loaded. The same weather pattern that would have produced a bad flood on the old baseline can produce a worse one on the new baseline, simply because there is more moisture and more energy available for it to work with. The speed of this particular Pacific flip is worth dwelling on, because the numbers tell a striking story. Trace the index season by season, and you can watch the ocean change its state in near real time. It sat at negative 0.54, La Niña, and then climbed to negative 0.37, then negative 0.14, then crossed into positive territory at positive 0.13, then positive 0.51, and now positive 0.98. That is a steady, rapid march from one regime to its opposite in the span of roughly a year, and it means the atmosphere is being pushed by a Pacific that is not settling into a stable state, but actively strengthening toward El Niño. A strengthening El Niño tends to inject more energy into the subtropical jet stream and can make the overall flow more amplified, which is to say more prone to exactly the kind of big ridges and deep troughs we are watching today. And the deeper driver, the one that outlasts any single El Niño, is the accumulated heat in the oceans themselves. The oceans absorb the overwhelming majority of the excess heat trapped by a thickening blanket of greenhouse gases, something like 90% of it, and that heat has been building year after year, setting records repeatedly. A warmer ocean surface means more evaporation, more water vapor rising into the atmosphere, and more energy available for storms of every kind. So when a pattern like today's dome sets up, it is drawing moisture off a Gulf of Mexico that is warmer than it used to be, and feeding it into an atmosphere that can hold more of it. The El Niño is the loud, temporary signal riding on top of a quieter, permanent rise. Both are real, and it is the combination that loads the dice. This is the honest way to think about the connection between today's weather and the warming climate, and I want to be very careful here, because this is exactly the kind of thing that gets exaggerated in both directions. It would be wrong to say that climate change caused today's tornado threat, or today's flood. Individual weather events are the product of specific short-term atmospheric setups, and stuck domes and rare severe outbreaks happened long before the baseline warmed. But it would be equally wrong and equally dishonest to say the baseline is irrelevant. The most defensible statement, the one the science actually supports, is that a warmer, moister atmosphere makes extreme outcomes more likely and more intense when the pattern lines up to produce them. It does not create the pattern. It amplifies what the pattern can do. The dome brings the fuel and the moisture to the table. The warmed baseline decides how much is on that table to begin with, and that finally is a real answer to the question of why the rare keeps feeling routine. Part of it is that these patterns have always existed and always will. Part of it is that we now see and measure and broadcast every one of them in real time, in a way that was impossible a generation ago, so we are simply more aware. But part of it, the part that is genuinely worth being sober about, is that a warmed baseline shifts the whole distribution of possible outcomes toward the extreme end. When you load the dice, you do not change what a single roll can be, but you change how often the high numbers come up. A stuck dome over a warmer planet is more likely to produce the kind of two-faced opposite extreme day we are watching right now, not because anything about the physics is new, but because there is more energy and more moisture in the system for that physics to act on. I want to bring this all the way back to the ground, to the person standing under one edge of the dome tonight, because this is not an abstract climate lecture. It is the reason today looks the way it does. The family in northern Maine watching the sky, the driver in the Texas hill country deciding whether to cross a flooded road, the farmer in the northern plains under record heat, are all living inside the same loaded system. The pattern that put them there is old and natural. The intensity it is capable of is, in part, new. That combination, an old pattern with a new ceiling, is the real signature of this era of weather, and it is why days that used to be once in a generation can start to feel like once a season. Now, whenever a day like this unfolds, with disasters breaking out simultaneously across the country, another kind of explanation always starts to spread, one that has nothing to do with jet streams or ocean temperatures. It is the idea that this is too coordinated to be natural, that someone is doing this on purpose. And rather than roll my eyes at it, I think it deserves an honest hearing and an honest answer, because the instinct behind it is more understandable than it first appears. So let me take those theories seriously for a moment, and then show you exactly where the science actually stands. Part 13. The idea that someone is doing this. On purpose. When two disasters strike opposite ends of the country on the same day, a very old human instinct wakes up. It whispers that this is too neat, too coordinated, too much at once to be an accident, and that someone, somewhere, must be behind it. Every time a day like this happens, the theories spread, that the storms are being engineered, that a secret facility is steering the weather, that the government or some hidden hand can turn the sky into a weapon and is doing exactly that. I am not going to mock anyone who has felt the pull of that idea, because the instinct underneath it is actually reasonable. The human brain is built to find agents behind patterns, and a day where fire, flood, tornado, and record heat all arrive together genuinely looks designed. So let me take the strongest version of these theories seriously, and then tell you, as honestly as I can, where the science actually stands. The most common version points at weather modification, and it usually names one of two things. The first is cloud seeding. And here is the part that surprises people. Cloud seeding is real. It is not science fiction. Operators disperse tiny particles, often silver iodide, into clouds to give water droplets something to freeze onto, and under the right conditions it can nudge a cloud that was already going to rain into raining a little more efficiently. So the kernel of truth is real, and I will never tell you otherwise, but look at the scale of what cloud seeding can actually do, versus the scale of what we are watching today. Seeding can coax a bit more precipitation out of an existing cloud. It cannot conjure a continental heat dome the size of a third of the country. It cannot manufacture 50 to 60 knots of wind shear over New England, or aim a river of Gulf moisture into Texas for days, or set the jet stream splitting around a ridge. The energy involved in today's pattern is staggering, vastly beyond anything human technology can inject or steer. Seeding is a garden hose. The dome is an ocean. The second name that comes up is a research facility in Alaska, often invoked as a kind of all-purpose weather weapon. In reality, it is an ionospheric research instrument designed to study the very upper atmosphere, hundreds of kilometers above where weather happens. There is no known physical mechanism by which it could reach down into the lower atmosphere and move storm systems, build ridges, or steer floods. The weather we are describing lives in the bottom several miles of the atmosphere and is driven by the sun heating the planet unevenly, by the rotation of the Earth, by the temperature of the oceans. Those are forces measured in quantities of energy that dwarf anything humanity can produce on purpose. When you actually run the numbers on the energy budget, the idea of engineering a pattern like this simply does not close. There is not a hidden machine big enough. If you want a single, decisive way to see why weather modification cannot explain a day like this, look at the energy budget because it is not close. The amount of energy involved in a single large thunderstorm complex is comparable to that of a nuclear detonation, and a continental heat dome represents that many times over, an amount of energy so vast it is measured in figures that have no human comparison. The sun delivers energy to the Earth at a rate of well over 100,000 terawatts, and the weather is simply the machinery that redistributes a fraction of that colossal input. Every human power plant on the planet combined produces a rounding error against it. There is no facility, no technology, no secret machine that can inject or steer energy on the scale required to build a ridge the size of a third of a continent. The mismatch is not a matter of a few times too small. It is a matter of many orders of magnitude. When you actually do the arithmetic, the engineered weather explanation collapses under its own numbers, which is the most honest reason to set it aside. So here is where the science lands, and I think it is more interesting than the conspiracy, not less. What we are watching is a blocking ridge, one of the most well understood, thoroughly documented, naturally recurring features in all of meteorology. Its two-faced behavior, dry violence on one flank and wet catastrophe on the other, is not a sign of design. It is a sign of geometry. A dome of high pressure, by its very shape, spins its flow one way on one side and the other way on the other, and that is all it takes to produce opposite disasters at opposite edges. It looks coordinated because it is coordinated, but the coordinator is physics, not a person. The pattern is doing exactly what the laws of fluid motion say a pattern like it must do. That is, to me, a deeper and stranger thing to sit with than any secret machine, because it means the atmosphere can produce this on its own, has always been able to, and needs no author. There is a second, milder form of skepticism that deserves an answer too, and it is almost the opposite of the first. It says the forecasts are hyped, that the big scary outlooks always get downgraded, that the tornado threat over Maine will fizzle, and the whole thing is fear for clicks. And you know what? That skepticism also has a kernel of truth, and today's own data proves it. As we have said repeatedly, at the time this forecast was pulled, there were 0 confirmed severe reports anywhere in the country. The setup is a projection, and projections sometimes verify weekly. It is entirely possible that tonight underperforms the forecast. But the honest response to that is not to dismiss the threat. It is to explain the ingredients clearly, state the uncertainty out loud, and let people prepare without either panicking or scoffing. A setup with this much fuel and shear deserves respect, even if it ends up underperforming, because the cost of respecting it and being wrong is a quiet evening, while the cost of dismissing it and being wrong could be a life. That is the whole philosophy of this channel in one sentence. Explore the fear honestly. Follow the data. Refuse to either sell panic or wave away a real threat. And that same honesty points us toward one genuinely reassuring truth on a day full of hazards, a place where things really are calm. Because while the lower atmosphere is doing everything at once, the environment just above it, the realm of the sun and space and the cosmic forces this channel so often watches with worry, is today remarkably, almost boringly, quiet. And that contrast is worth a look, because it tells you something important about where the danger actually lives right now. Part 14. The calm directly overhead. On a channel like this one, we spend a lot of time looking up, past the weather, into the realm of the sun and the solar wind, and the deep cosmic forces that can, on the wrong day, threaten the technology our whole civilization runs on. So it is worth telling you plainly that today, That realm is quiet. Almost eerily so, given how violent things are down here in the bottom few miles of the atmosphere. The sun, so often the villain of our stories, is behaving itself. The numbers tell the calm story clearly. The space weather scales that track solar radiation, radio blackouts, and geomagnetic storms are all sitting at their baseline, essentially zero across the board. The strongest measure of geomagnetic disturbance in the past day peaked well below even the weakest storm threshold. Solar activity is low, with only minor background flaring and no significant eruptions aimed at Earth. There are no Earth-directed coronal mass ejections in the current imagery, no incoming blast of solar plasma to worry about. There is a chance that a glancing blow from an earlier eruption could stir up some unsettled conditions in a day or so, the kind of thing that might produce aurora at high latitudes but nothing remotely dangerous. After weeks where this channel has watched the sun throw flares and hurl plasma toward us, today the star is calm, and our power grids and satellites can rest easy on that front. To give you a sense of just how far from any threshold the sun is sitting, consider the specific measures. The index that tracks geomagnetic disturbance peaked over the past day at a value below 4, when it takes a reading of 5 to reach even the weakest official storm level. The solar wind, the stream of charged particles flowing off the sun, was moving at a modest few hundred kilometers per second, well within its calm range, and the orientation of its magnetic field was pointed in the direction that shields the Earth, rather than the one that lets energy pour in. The sun's X-ray output was sitting at low background levels, with only a minor flare or two in the past day and nothing approaching the powerful flares that cause radio blackouts. Even the sunspot number, the running tally of dark active regions on the sun's face, has been trending down compared with a year ago, a sign that this particular solar cycle may be easing past its most active phase. Every single dial that this channel watches for danger from above is reading quiet. The solid Earth is relatively quiet too, at least in terms of anything catastrophic. Globally, seismographs have recorded just over 100 earthquakes of magnitude 4.5 or greater in the past week, which sounds like a lot but is well within the normal background rhythm of a restless planet. The notable events, a magnitude 5.6 deep beneath Peru, a 5.3 off the Alaska Peninsula, a handful of 5s around the Philippines and Japan, are the ordinary music of the planet's grinding plates, and none produced a major disaster. There was even a moment of ambiguity where a data feed listed an Alaska earthquake in a way that looked, at a glance, like it might involve a tsunami, but the official flag showed no tsunami threat. It is a good reminder to always check the authoritative source before sounding an alarm. As for the world's volcanoes, several are active in their usual way, an Alaskan volcano at a watch level, ongoing eruptions at places like Etna in Italy and Krakatau in Indonesia, but nothing that represents a sudden new global danger today. And above all of it, humanity is going about its business in space, almost serenely indifferent to the storms below. Even as Texas floods and Maine braces for the dark, a crewed spacecraft was set to launch toward the International Space Station, carrying new astronauts up and away from all of this. Rockets are flying, satellites are going up, a major test flight is on the schedule for later this week. Look up far enough today, and the trouble simply disappears. The chaos is not cosmic, it is not solar, it is not seismic, it is atmospheric, and it is entirely homegrown, generated by our own planet's air, water, and heat. I point all of this out not as a collection of unrelated trivia, but because the contrast is genuinely the point. On so many days, the thing this channel worries about is the danger from above, the flare that could knock out the grid, the asteroid that could threaten a city, the deep cosmic clock ticking towards some rare event. Today, all of that is calm, and the danger is entirely underneath it, in the ordinary lower atmosphere, in a dome of warm air and the storms it is throwing off its edges. It is a useful reminder that the most dangerous thing on any given day is not always the most exotic thing. Sometimes the sky above is perfectly peaceful, and the real threat is the humid air a mile over your head, organized into a pattern that is doing everything at once. That contrast also sharpens the central truth of this whole story. The danger today does not come from some external force acting on the Earth. It comes from the Earth itself, from the way our own atmosphere redistributes heat and moisture, from a single ridge of high pressure parked in the wrong place at the wrong time. The sun is quiet, the ground is steady, the cosmos is calm, and yet millions of people are in harm's way, because the trouble is coming from the thin shell of air we live inside, from a pattern that needs no help from space to become dangerous. Everything threatening people today was generated right here, by the planet, out of ordinary summer heat and Gulf moisture and the geometry of a dome. So we have now walked the whole circumference of this thing, the rare tornado threat on the north edge, the catastrophic flood on the south edge, the record heat at the centre, the fires on the western flank, the warmed baseline underneath it all, the honest reckoning with the theories that say it must be designed, and the quiet, calm cosmos overhead that proves the danger is entirely our own planet's doing. What remains is the part that matters most, the part that all of this has really been about from the first sentence. Not the physics for its own sake, but the people, the millions of human beings living at the edges of this dome tonight, and what this whole strange, connected, two-faced day actually asks of them. Part 15. The millions in between. Strip away the physics for a moment and look at who is actually standing under this dome tonight, because in the end that is the only thing that makes any of it matter. The title of this story is that millions of people are in the way, and that is not a figure of speech. It is a literal accounting of the human beings living along the edges of this pattern right now, each of them facing a different face of the same system. In the northern woods of New York, Vermont, New Hampshire, and Maine, there are families settling into a hot July evening, many of them with no deep instinct that tonight is different from any other summer night. Some of them live in homes without basements, some in mobile homes, in a region that has almost no practice with the kind of storms the forecast is warning about. 1,000 miles south, in the hill country of Texas, there are people watching creeks that were dry gravel this morning, weighing whether the road out is still passable, some of them already cut off by water. Across the northern plains there are farmers and construction workers and elderly people in homes without adequate cooling, facing a heat that kills more Americans in a normal year than any storm. And out west there are communities living under smoke, watching fire lines, hoping the wind does not shift. All of them, at once, under one pattern. That is the true scale of today. What I want to offer these people is not fear, because fear is useless. It freezes you or it exhausts you, and neither one keeps you safe. What is useful is a clear picture of the threat and a small number of concrete actions, and those actions are different depending on which edge of the dome you are standing on. If you are in the northern New England threat zone tonight, the single most important thing is to have a way to be warned that will reach you after dark, a weather radio or emergency alerts on your phone, so that if a warning is issued for your exact location while you sleep, something wakes you. Know now, before dark, where you would shelter, an interior room on the lowest floor away from windows, and if you live in a mobile home, know where the nearest sturdy building is, because a mobile home is not a safe place to ride out a strong wind or a tornado. If you are in the Texas flood zone, the message is even simpler. Do not drive into water. Turn around. Do not drown. No trip is worth it, and the water will go down. And if you are under the heat, drink water before you're thirsty. Find air conditioning even if only for a few hours. Check on the elderly and the isolated, and take the overnight warmth seriously, because it is the nights that kill. I also want to be honest, one more time, about what we do not know, because false certainty is its own kind of danger. As of the data behind this forecast, not a single severe storm had been reported anywhere in the country today. The tornado threat over Maine is a projection, a well-founded one, but a projection, and it is entirely possible the evening underperforms it. The Texas rainfall totals could land lighter than feared if the storms shift, or heavier if they park over a city instead of open country. The exact track of the worst of it, in both places, genuinely cannot be known until it is happening. So I am not here to tell you a disaster is certain. I am here to tell you the ingredients for one are on the board. The professionals whose job is caution are using unusually strong language, and the responsible thing is to be ready without being consumed by it. That balance, taking a threat seriously without surrendering your evening to dread, is the hardest and most important skill in living with weather like this. Let me make the preparedness advice as concrete as possible, because vague reassurance helps no one, and specifics save lives. For the northern New England threat, the single highest value action is enabling wireless emergency alerts on your phone, the ones that come through automatically for tornado warnings and flash flood emergencies, and making sure the volume is up loud enough to wake you. If a tornado warning is issued for your location tonight, you may have only minutes, and in the dark, that alert may be the only warning you get. Identify your safe spot now, before dark. The lowest floor, an interior room, a bathroom or closet away from windows. And if you are in a mobile home, decide right now where the nearest sturdy shelter is and how you would get there quickly. For the Texas flood zone, never attempt to cross a flooded roadway, even one you have driven 1,000 times, because the roadbed may be gone beneath the water and barricades exist for a reason. And for anyone under the heat, the overnight hours are the ones that matter most, so find a way to cool down at night, because it is the lack of nighttime recovery that turns a heat wave into a mass casualty event. These are small actions, and that is exactly the point. The gap between a near miss and a tragedy is often not some heroic effort, but a phone with alerts turned on, a decision to turn the car around, a few hours in air conditioning. The atmosphere has assembled something enormous today, but the human response that keeps people safe is made of very small, very ordinary choices made in advance. There is a reason this connected way of seeing today matters beyond just being interesting, and it comes back to the people. When you understand that the Maine tornado threat and the Texas flood are the same pattern, you understand something the fragmented news coverage will not tell you. You understand that this is not a run of bad luck, 3 separate rolls of the dice that all came up bad. It is one loaded system doing what its shape dictates, and that understanding is what lets you see the next one coming, because a pattern like this does not vanish when tonight's storms weaken. It moves, it evolves, it reloads. The dome that is throwing storms at New England and rain at Texas tonight is already forecast to shift, and when it does, it is going to point its edges at a new set of cities and a new set of people. That is the thing I most want you to carry out of all this. The danger is not just tonight, and it is not just these places. It is the pattern itself, and the way a warmed baseline lets that pattern hit harder than the patterns of the past. The millions in the way tonight are not the last millions this dome will threaten this week. They are simply the ones standing under its edges right now. And the honest question, the one this whole day has really been building toward, is not which of tonight's hazards turns out to be worst. It is what happens next, as this same system pivots east and decides who is standing under its edges tomorrow. So let me take you there, to the last piece of this, and to the question that does not have an answer yet. Because the dome is moving, and the models are already showing where it goes, and the story of this week is not finished, it is barely halfway told. Part 16. The dome is moving. A stuck pattern is never truly permanent. It is only stubborn. And the dome anchored over the country today is, even now, beginning to shift, sliding eastward, and as it moves, the edges that are threatening Maine and Texas tonight are going to swing across new ground. This is the part of the story that has not happened yet, the part still being argued over inside the computer models, and it is why tonight is not an ending but a hinge. As the ridge slides east through the week, forecasters are watching for it to throw storm fuel into new regions, the Mid-Atlantic and the Ohio Valley, where the same combination of heat, moisture and disturbances riding the ridge's edge could set off new rounds of severe weather in the days ahead. The heat that is breaking records in the plains today is expected to ooze into the east, pushing the Mid-Atlantic toward triple digits, and down in Texas the flood threat does not end with tonight, because the pattern that traps the storms is forecast to hold through Thursday, and possibly beyond, meaning the same rivers we named are expected to keep rising, and the same saturated ground is expected to keep shedding water. The dome does not release its grip all at once. It loosens slowly, and it does damage the whole way out. This is the deepest lesson of a day like today, and it is worth stating plainly. We tend to experience weather as a series of separate events, a storm here, a flood there, a heat wave somewhere else, each with its own name and its own news segment. But the atmosphere does not work in separate events. It works in patterns that persist and evolve and travel, and a single pattern can wear many faces across many days and many places before it finally breaks down. The tornado threat over Maine and the flood over Texas are not two stories. They are 2 hours in the life of one system, and that system has more hours left in it, aimed at people who are not yet paying attention because tonight the danger is somewhere else. And underneath all of it sits the harder truth we kept circling. Patterns like this have always existed, but they are now forming over a warmer planet, over oceans running hotter than the historical baseline, with an atmosphere that holds more moisture and more energy than it used to. That does not create the dome, It raises the ceiling on what the dome can do. A century of forecasting was built around patterns behaving within a certain range, and the range itself is quietly shifting. The rare setup that forecasters almost never see, the one that flooded Texas and threatened Maine on the same afternoon, may not stay quite so rare. That is not a prediction of doom. It is an honest reading of a loaded system, and the most useful thing it can do is make us pay attention sooner to the pattern rather than just the event, to the next edge rather than only the one over our heads tonight. It is worth being specific about what the next act could look like, because the ingredients are already assembling. As the ridge shifts and its heat pushes into the east, the same recipe that made today dangerous, hot, unstable air, with disturbances riding the edge of the ridge, can set up again over more heavily populated ground. The Mid-Atlantic and the Ohio Valley are home to tens of millions of people, and they sit squarely in the path of where this pattern is forecast to reload storm energy in the days ahead. The heat alone is a story there, with the Mid-Atlantic forecast to push toward 100 degrees, but the same edge dynamics that spun up today's storms could bring new rounds of severe weather to that corridor as the week goes on. And in Texas, the flood does not clear when tonight ends. The rain is forecast to keep training over the same watersheds through Thursday and possibly beyond, which means the rivers we named are expected to keep rising, and the danger to keep compounding on already saturated ground. The forecast confidence drops the further out you go, and the models are genuinely still arguing over the details, but the broad signal is clear. This pattern has more to give. So here we are, at the end of the day but not the end of the story. One dome, anchored over the heart of a continent, spinning off a rare tornado threat on one edge and a catastrophic flood on the other, baking records into the middle and burning the western flank with millions of people standing at its edges and more of them about to be. The sky above is calm, the ground is steady, and yet the ordinary air we live inside has organised itself into something that can do all of this at once. That is what forecasters rarely ever see, and it is the reason to keep watching. Because tonight, as the sun goes down over the northern forests of Maine, the atmosphere is loaded and the storms have not yet done what the forecast says they can do. Somewhere out in that country, a family is going to sleep with a phone on the nightstand set to wake them if a warning comes in the dark, and 1,000 miles south, a creek is still rising in the rain. Both are living inside the same pattern, at the same moment, at opposite ends of the same dome. So the real question, the one none of us can answer until the dark hours are over and the water finally crests, is this. When the sun comes up tomorrow, how many of those millions at the edges will have watched the storm pass them by? And how many will wake to find that the rarest setup forecasters ever see was not a warning that missed, but one that landed,